All right, so look at the two problems of the day. Pause the video and solve them before you move on. Today we move on to lesson 4.6, which is perform operations with complex numbers. So complex numbers, we'll talk about them in a second. Complex numbers are used in the form of, call it A plus BI, which are made. So A plus BI, I'm going to add this actually here, made up of real and imaginary numbers. You might be wondering, well, what are you talking with imaginary? Complex numbers have two parts, plus or minus sign between them. A and B are some actual number, but the I stands for imaginary. Now, imaginary, that's interesting. If you think about it for a second, if we go back to problems, if I told you before square root of 4, you would say it's 2, right? But what if I added a negative to it? We, up until this point in math, have never dealt with negative numbers inside the square root. They are called imaginary numbers. Not all quadratic equations have real number of solutions. All right, so if we come up with a negative, we call it something called imaginary. The reason why we need to have imaginary in order to overcome this problem, math has created an expanded system of numbers using the imaginary unit I, which is the square root of any negative number. So we are adding numbers. Up until this point, you've only dealt with real numbers. We're now adding the imaginary spectrum. So we'll talk about it a little more as we go. Imaginary unit, I equals negative square root of 1, and then note that I squared equals negative 1. So look at some properties here. If I have the square root of negative r, we'll call it r. We're going to call that now I square root of r. So the negative inside the root now just comes out to the front as an I. So let me give you an example here. If I told you negative square root of 3, we would now say it's I root of 3. I for imaginary. All right. If I give you, though, here's another one, quantity I square root of r squared, that's going to equal negative r. So if I give you I square root of 3 squared will equal negative 3. And we'll see more examples as we go. All right, well, let's look at a problem with solving square roots. It's exactly like the last lesson, but now we deal with imaginary numbers. So first we have 2x squared equals, let's take the 11 over as negative 11. We get negative 37 minus 11 is negative 48. We divide both sides by 2, so we get x squared equals negative 24. And we're going to now take the square root of both sides, just like before. But what do you notice? Now you see that we have a negative inside the root. So when we do that, we get x equals, don't forget your plus minus. And actually, I'm going to write this part out. So plus minus, whenever I take the square root from last lesson, the negative 24, the negative comes out as an I. Don't forget, we could actually split up 24 to 4 and 6. So my final answer is x equals plus minus 2I root of 6. And conventionally in math, when we get the whole number, it goes in front of the I. So x equals plus minus 2I root of 6. So we're doing the same exact thing that we did last time, except now we have a negative for the root. So let's take a look at another one. We're solving algebraically. We take the square root of both sides. We get x equals plus minus I root of 13. Here, we're going to add 8 to both sides, or transpose the 8 over as a positive. We take the square root. And 28 could be what? 4 times 7. X equals plus minus 2i root of 7. All right. So let's do the next one. I'm going to pause the video. I want you to try solving yourself, and then I'll do the work as well when you resume the video. So try the next two. So let's look at example 2. Hopefully you had a chance to solve it. We first subtract 18 from both sides. We get 2x squared equals negative 90 right here. Then we divide both sides by 2. We get x squared equals negative 45. Take the square root. X equals plus minus 3i root of 5. How did I get 3 root of 5? 9 times 5 is 45, right? So keep in mind the rules we did in the last lesson. Here we add 7 to both sides. 3x squared equals negative 24. Divide both sides by 3. X squared equals negative 8. Take the square root. X equals plus minus 2i root of 2. So the only new part is we're adding I for the negative root. All right, adding and subtracting, or addition and subtraction of imaginary numbers, think of like terms. I think of the i's as like terms, as any variable pretty much you could think of, and other numbers. First, the only extra part here is we have to distribute the plus to both, and in here we would distribute the minus to both. So be careful. I'm going to rewrite it, dropping parentheses. I'm actually going to type it out. This one's easy to type out. So 12 minus 11i is okay. Now, plus times negative is negative. Negative 8. Positive times positive is plus positive. And now what we're going to do is we're going to combine like terms. 12 minus 8 is 4. Negative 11 plus 3 is negative 8. Attach the I. And that's all you're doing for these. So I think these are pretty easy. Once again, 12 minus 8 is the 4. Negative 11i plus 3i. We combine the front numbers and attach the variable. Now be careful with the next one. First part's okay, 15 minus 9i. Be careful, I distribute the negative to both. Negative is where it can change the sign. I get negative 24 plus 9i. From there, I just actually get negative 9. And you might be wondering how that happened. These two cancel out, they make 0. So in this case, I have a single number. Another thing I want to bring a point back to is if you look here, these are complex numbers, 4 minus 8i. You have a regular number and an imaginary. So let's take a look at the next one, the last one here. Don't forget to distribute those signs out front. And we simply combine like terms. 4 minus 3i is my final answer. So I think these are pretty easy. All right. Now for the next part here, let's take a look. We also have to remember that negative 1 equals I squared. Remember back from the beginning of the lesson. So we had, like, if you take the square root of a negative number, just an I, but I squared equals negative 1. So what I'm going to do, I know I squared equals negative 1. So let's combine two of the i's. So that will give me, parentheses, I squared times I. I squared we see here is negative 1, so we get negative 1 times I, or negative 1i. And that's actually going to be my answer. So in this part of the lesson, we're taking a look at the fact that I squared equals negative 1. Here we'll distribute 4i to both. So I get negative 24i plus 4i. Don't forget this is a square. And if we rewrite it, we're going to take the I squared and change it to negative 1. So we're changing the whole I squared there. And then we're going to get, when we multiply 4 times negative 1, we get negative 4. And conventionally, complex number, we put the negative first, or the regular number first, and the I second. So how I'd like you to write the answer is -4 minus 24i. Last one we have to FOIL. So let's do first. You could try it as well. So we do first outer, inner, last of FOIL. Here we're going to do two things in this next step. I'm going to rewrite the -8. I'm going to combine these two in the middle to get 16i, right? And don't forget, I squared is -1. So you see I actually write it here. -6 times -1 is +6. And last but not least, we could combine like terms. I get -2 plus 16i. Now that's my answer. So we combine these and multiply those out. Last part where we need to take a look at deals with multiplying by the complex conjugate, which is like rationalizing the denominator almost. We did that in the last lesson as well. This is, and by the way, this says denominator in case you're not sure. So if the denominator has a plus bi, we're going to multiply it by a minus bi. So we do the opposite sign, just like the square root ones we dealt with in the last lesson. If we have a minus in between them, we do by a plus bi. Now let's see how that applies to us. All right, so we're going to times the top and bottom by what's in the denominator, change the sign. With a plus sign. And how the square root ones worked, we're going to follow the same logic. We distribute the 3 to both. So we get 6 plus 3i. Now if you remember before, we do the first and last of FOIL. So here's FOIL. We don't need the OI because it's a special pattern, it cancels out. So we do the first. First, 2 times 2 is 4. Last, -i times +i is -i squared. And don't forget, and I'm going to write it below it, that you have to actually take care of what I squared is, which is a -1. And 4 minus -1 is 4 plus 1, which is 5. So you get 6 plus 3i over 5. That's our final answer. So take a minute, do the next two. I'm going to pause the video. You could try it yourself to show you the work. Don't forget the last one, we're going to have to FOIL for that. So take a look at letter B, check your work. It should be 1 minus I for both of them. And then check out your, anytime you see I squared, change it to -1. And then C, be careful, the top you FOIL. I have to combine like terms and then plug in -1 for I squared. So for C, you get 2 plus 10i over 13. Check your work. Last but not least, we're finished with the lessons. Complete the problem of the day, and then do problems 2 and 3. And that's it for today.